All right, so now we're going to go back to solving trig equations, and but we're going to be manipulating using our different formulas that we have now. So let's see how this guy's going to work. We're going to solve for 2 minus sine squared of x equals 2 cosine squared of x minus 2. Yeah! Nerdiness all the way. No joke about that. Okay, so normally when we solve, we like it all in terms of sine and cosine. Normally that's a safe approach there. So this is in sine already. If I look at this sign, cosine squared of x over 2, I know that the half angle formula will give me cosine again, but I think we'll be able to make some changes at the end here. So let's just do that then. Let's just go ahead and maybe replace our half angle, and let's just see where we get to here. So we have 2 minus sine squared of x equals 2. Now what I want to do is replace my cosine of x over 2 with the half angle formula. So that's plus or minus radical of 1 plus cosine of x all over 2. And all that right there is squared. Okay, so all I do is I just replace my cosine of x over 2 squared. I replace that with that guy right here. So leaving the left side the way it is, if I square it, then all of a sudden the radical just gets eliminated. So it's 2 times 1 plus cosine of x all over 2. Okay, so we have that guy right there, which then means my 2's cancel out. So I'll just write that there so it's nice and good there. So we have just 1 plus cosine of x. Oh. All right, well, now we have it in cosine, and this looks like maybe we can use the Pythagorean theorem, or I'm sorry, the Pythagorean identity, and we can write this in terms of cosine. So this is going to be 2 minus, that's 1 minus cosine squared of x equals 1 plus cosine of x. Okay, so simplifying all this over here, I get 2 negative times our positive is a negative 1. Negative times negative is a positive. Cosine squared of x equals 1 plus cosine of x. All right. Let's get 0 on the right side by just maybe moving everything over to the left. So that means I'll have my cosine squared of x right here, right? If I move this negative 1 over, I'll have negative 2. So 2 minus 2 is 0. So my constants cancel out. And if I move my cosine over, I'll get minus cosine of x equals 0. Awesome. Well, we have a common factor of cosine. So I'm going to factor that little dude out. And I get cosine of x minus 1 equals 0. And now we set each factor equal to 0. So cosine of x equals 0. Cosine of x equals 1, because I'm going to go ahead and just add the 1 right now. And so let's see, when is x 0? Well, that's at pi over 2 and at 3 pi over 2. And when is cosine 1? Well, that's just at 0. So those are our 3 answers. Now, if we go back up here, way back up in the days over here, see how we squared both sides? And we must remember, if we square both sides, that's an indication that it's possible. It's possible to have an extraneous solution, meaning that we derived a solution down here, but it really isn't a solution. Okay, I went through all of them, and they all checked out. On the next example, I'm going to show you how one of the answers actually doesn't work, but for the sake of this example here, take those 3 values and plug them in just straight into x, and you should get the left side always equals the right side. You know it's not true when you get an unbalanced equation.